Okay, so we're talking about how to find now tensions in cable A and in cable B. So we said that C will act downward from the point towards the cable, and we know its magnitude from previous step. So now we still have to get tension in A and tension in B. So we need two equations, which are the equation of equilibrium. The first equation is sum of forces along x equals to 0. So we project along x direction. This is our x direction. We have plus TB cosine 30 minus TA cosine 40 and minus TC cosine 60 equals to 0. This is equation number 1 relating the two unknowns B and A. We need another equation, so we project along the second direction, along y. When you project along y, sum of y equals to 0 will give us the projection of B is B sine 30. The projection of A is A sine 40. And finally, the projection of this force is C sine 60. Okay, so solving these two equations, we have two equations with two unknowns. We can get then what is the values of A and B. Okay, any question on this problem? Let us try to solve another problem on
عندنا two systems لكن وشو بنعمل؟
مظبوط. صار عندنا two equations with two unknowns. يعني على calculator you can solve it or you can solve it by substitution انت بعقيدك يعني it's simple. بس you can use the calculator if you want. Okay. تدربوا على solution of systems in calculator. إذا بدكم تستعملوا الكالكوليتر بدكم تحطوا in your calculator بتحطوا الايكويشنز تحت بعض. بتنقوا مثلا انه A هي first variable, B second variable. So whenever you enter a system of equations هيدا النمبر بيكون coefficient of variable 1. يعني بأول لاين بتحطوا هيدا النمبر وهيدا النمبر for the second variable وعلى طول بالكالكوليتر بيكون الثيرد نمبر هو من بعد الايكوال. انتبهوا لهيدي غير السكند ديجري. بالسكند ديجري بالكالكوليتر A B C كلهم قبل الزيرو. يعني A x square plus BX plus C equals to 0. ال A B C هن الكويفيشنت before الايكواليتي. بينما هون بالسيستم of two equations two unknowns او three equations three unknowns هيدا النمبر بناخده لبعد الايكوال. So in your calculator you will plug على أول line minus 0.766, 0.866, 1413. In the second line you will put 0.643, 0.5, أو 2.447. ساعتها when you solve أول variable بتكون A وثاني variable بتكون B. Okay. Any question on this? Okay. Yeah. Another example, we have springs AB and BC have a stiffness of 500 Newton per meter and a non-stretched length of 6 meters. Determine the horizontal force F applied to the cord, which is attached to the small pulley B, so that the displacement of the pulley from the wall is D equal to 1.5 meters. So in this problem, you have springs. And these springs were initially unstretched at the vertical position. So when they were at this position here, they were unstretched. This means that no force is, whenever your spring is unstretched, the force developed within your spring is 0. So here you have the lengths. Each of your springs is at its unstretched length, which is because the summation of lengths is 6, and we have the two springs have equal lengths. So each of them will have L0, which is the unstretched length, equals to 3 meters. Now, they told us that we applied a force on our springs and this force is horizontal. Under the effect of this force, point B will move along the horizontal direction. And we want to find what should be the value of the force F to displace B by 1.5 meters. And just when we reach 1.5, we establish equilibrium conditions. So the question is to find what is F, for which we have equilibrium condition at a distance from the vertical position of 1.5 meters. So when we reach this position here, we are at equilibrium. And we know that this distance is 1.5. And we want to calculate the value of F. What is the methodology to use here? What should we do? We should say B is our point of interest, and we have several forces acting on B. For B to be at equilibrium, sum of forces at B should be 0. So this horizontal force F plus the effect of the two springs. So you have the tension T1 in spring 1. You have the tension in spring 2, T2. And from the figure, you can calculate the inclination of T1 and T2. So this angle is theta, and this is also theta because of symmetry of the figure. Yani you have that this distance is 1.5. This is 3 meters. So you can find simply theta by saying that theta is tan minus 1 of 3 over 1.5. So you can calculate your angle. Okay. Now, next step, what are our unknowns? I have the tension T. Yes, I have T1, I have T2, and I have F. So I have in total 3 unknowns. Okay. And I can write only 2 equations. So how can I go over this? First, T is a tension in what? In a spring, okay? And you know that whenever I have a spring, how to calculate the tension in the spring? What should I do?
عنا stiffness وعنا initial length final length.
Very good. عنا initial length L0 unstretched. عنا at this position, what is the total length of the spring? We do Pythagorean theorem. So we have, this is 1.5 and this is 3. So AB is radical of 1.5 square plus 3 square. So now we can calculate, if you want, calculate the value of the tension by saying that T is equal to K delta L. So T1 is equal to K delta L1. And because of symmetry, Aslan, if you paid attention for symmetry, you can directly say that T1 is equal to T2. لأنه we have same K and we have same delta L. Delta L1 and delta L2 are equal. So T1 will be equal to T2 by symmetry effect. You can also demonstrate this again if you didn't pay attention for the symmetry effect when you project along Y. Because if you project sum of forces along Y acting on B, you have only T1 and T2 have Y components. Force F has no components along Y. So when you want to do sum of Y equals 0, you have here same angle theta. The angle here is equal to this one. So you have a positive projection for T1 and a negative projection for T2. So when you write sum of Y equals 0, so this is T1, this is T2, and you have, as you can see here, the angle with the horizontal is the same. So now if you project along Y and you write sum of Y equals to 0, you will get that plus T1 sine theta and minus T2 sine theta equals to 0. And since the angle is the same, sine theta will simplify. And then you can just write that T1 and T2 will cancel out. Sine theta will cancel out. So T1 is equal to T2. And you can conclude also this due to symmetry. You can directly say due to symmetry, T1 equals to T2. Okay. So, or some Fy or the symmetry condition will give you that we have same tension force. Now, what is my tension? As you said, it's K delta L. So this is how I can calculate TT is K times delta L. So now my only unknown is F. To get F, I project now along X. I say, since I have equilibrium condition along X, I can write that sum of X is equal to 0. And because sum of X is equal to 0, then I have plus 2t cosine theta and minus F equals to 0. So only unknown is F. I get the value of F. Okay. Any question on this problem? Okay. Another problem with pulleys. You can encounter several systems, complex systems with pulleys. We have already considered pulleys in our study of dynamics, but here, if you want, you have more complex systems of several pulleys involved. And the question here is to determine if we have equilibrium conditions, what will be the weight of the block? And this example is to explain for you that what is the purpose of a pulley system? A pulley system will allow you with a small force to hold a very large, a much larger weight. Okay, why? Because you will use this force over several cables. So this will multiply the effect of this force. Let us see how. And if you just look as a first sight, maybe to the figure without doing the analysis, you can say if I put 50 lb, I can hold 50 lb weight. It's wrong. Okay, because you have a system of pulleys that will multiply the effect of this force. How? If we consider first, we are applying 50 lb at this level here. Okay, now let us follow our cable. The cable will start here, will turn over pulley D, will continue to go over C, and then is attached to the ceiling level. So it's one cable. Whenever I'm dealing with one cable, and we said that pulleys are frictionless, so the tension is not varying over the pulley is frictionless and massless also. We'll see why it's important to say that it's massless. You will understand this in the last chapter of rotation. If you have a pulley that is not massless, you can have different tensions through your cables. We'll see this together in detail in final chapter. But until now, we deal with frictionless and massless pulleys. So whenever, if I take any point on the cord, this means that the tension will be the same everywhere on the cord. So in particular, what are the points that interest me? These 2 points here. Because now if I do the analysis of pulley C, if I isolate pulley C, and I want to study what are the forces acting on it, I have, when I cut here, okay, I have the tension in this cable. And we said that in this cable, the tension is equal to 50 lb. So here I have 50. And here also I have 50. So to ensure equilibrium, the tension in this cable here should be 100. Okay, so now in my new cable, I have now a second cable here. This is my second cable. in my second cable, the tension is not 50, it's 100. Okay? And you can see by using this arrangement of pulleys, I was able to multiply the effect of 50. So when going through pulley C, I was able to double my effect from 50 to 100. Now, I will continue in a similar way. Now I will take as system this pulley B. Okay? If I take pulley B as system, now I have, when I do a cut here, I have 100. When I do a cut at this level here, also I have 100. So here I will have 100 plus 100, 200. Okay. Now I continue in the same way. Now I have a third cable. This is cable number 3. Again, okay. This cable is going through pulley A. So whenever I do the analysis of pulley A, I have 200 here, 200 here. And to have equilibrium of this pulley, then the tension in this cable here is 400. And because my block is in equilibrium, the weight of this block is equal to the tension in the final cable, to the tension in this cable. So I can say that my weight is equal to this tension is equal to 400. So you can see that with a force of just 50 lb, I was able to hold a block of 400 lb. From here, the importance of the pulley system. And it's used a lot, okay, to hold very large weights with a small force. More you add pulleys, okay, you can use then a smaller force to hold your system. Okay. Any question on this? Okay.
Okay.
Yeah. So
هذا البولي تبع اللحام كمان بتشتغل نفس
100% البولي تبع اللحام تشتغل على هذا الكونسبت. اوكي. You see إذا بتطلعوا اللحام عم بيعلل let's say حيلا شيء، اوكي، بصير هو يعمل يشد من هون بفورس صغيره وبيقدر يعلي البارت اللي هلا. بس نشتغل وقت يكون شغل مع اللحام بيكون في اكسلريشن. هلا هون equilibrium problem، بس نحن شفنا كمان بالسيستم اوف بوليز فيكم عندنا blocks in acceleration، يعني ساعتها we can correlate الاكسلريشن اذا بدكم يلي عم نشد فيها الكيبل هيدا بالاكسلريشن اوف البلوك. اوكي. واكيد
يعني
اكيد
بتخف الفورس
ايه، يعني اللي بيصير انه كل يعني هون اذا بتلاحظوا هو كيف عم بيشد، اذا عم بيكون الاكسلريشن تبعه اعلى، اوكي، اعلى من الاكسلريشن تبع البلوك، بس الفورس الويت للبلوك اعلى بكثير من 50. يعني هو بيقدر بهالنقطه يسرع. اذا عم نحكي باكسلريتنج كيس، الاكسلريشن اوف ذس بوينت او الفيلوسيتي اوف موشن اوف ذس بوينت هتكون اسرع بكثير من الفيلوسيتي اوف موشن اوف ذا بلوك، لانه بالاخر energy is conserved والباور is conserved. اوكي. انتم بتعرفوا انه الباور هو force times velocity. اوكي. the power is conserved. يعني انا اذا عم if I'm imposing a certain velocity v on my هون على هيدي البارت، اوكي، كل ما صغرت الفورس كل ما بقدر اسرع اكثر. فهيدا البلوك لانه هو ثقيل حيكون عم يمشي with a velocity that is lower. So from here also you can link velocities of the two using the concept of pulleys. يعني كنا ناخذ the length of the cord if you remember, and we derive it with respect to time to relate velocities of points, and we derive it again to relate acceleration of points. Okay. Any other question on this problem? طيب خلينا نعمل بعد one problem على rigid body. فتتذكروا شوي الايكويشنز على rigid body. هلا بالهومورك تبعكم في problems عن equilibrium بس يمكن I think انه هن particle. Anyway في problem اجى بفاينل عن الايكوليبريم of a rigid body. بس نرجع على الصف ان شاء الله next week. I will solve it for you. Okay. Now I will remind you of how to solve statics problems for in 3D يعني for rigid body. هلا نحن حنشتغل sorry in 2D بس rigid body مش particle. Okay, so let me zoom it a little bit. Okay. Let us consider this truss structure. Okay. هيدا الستراكشر هي a truss structure بيستعملوها بالصورة okay to let's say hold a certain load. Now we have the following system. The following system is subjected to several forces on it, and we want to find the reaction developed at the supports. إذا بتتذكروا وقت شفنا الكورس ماتيريال أنا وياكم قلنا إنه من السيمبلز you can know the type of reactions. Okay, whenever you see a triangle like this means that it can develop two reactions, one in X, one in Y, but it will not develop a couple because it allows rotation. Okay. يعني إذا بس عندي هيدا بن اسمه البن مثل المسمار. إذا أنتم بتدقوا مسمار بشيء فيكم تبرموا around the point بس ما فيكم تزيحوا ولا along X ولا along Y. So the developed reactions are AX and AY. Now, whenever you see a circle, this is a roller. A roller هو مثل wheel إذا بدكم كمان فيكم تتخيلوا عندي شيء واقف على wheel. إذا عندي شيء واقف على wheel وجربت أعمل translation in X, I can move. But if I try to push down on B, يعني أعمل downward action, the wheel will do opposition. The wheel will always do a force perpendicular to contact from the wheel towards the structure. يعني you have BY like this. Okay? And now, if you want to solve for your supports reactions, you need three equations because you have three unknowns, AX, AY, BY. Always, always, equilibrium of a particle in 2 dimension can allow you to just solve for two unknowns لأنه بس فينا نكتب sum of X equals 0, sum of Y equals 0. بينما when we have a rigid body, okay, we can write three equations in 2D. Sum of forces along X equals 0, sum of forces along Y equals 0, and sum of moment about any point on my figure equals 0. حتى إذا بتتذكروا وقت شو عملناها بالصف قلنا we have the freedom of, for example, taking two moment equations, one force equation. أو فينا نكتب كمان 3 moments equation. You can do whatever you want, بس مش أكتر من 3 equations. If you write a force equation, one of the equations will be redundant. يعني you will get in the same equation again, or in the same form, or in a proportional form. So you cannot write more than 3 equilibrium equation for a 2D rigid body equilibrium problem. Now, أكيد أهين شيء أهين two equations هني sum of X, sum of Y. برجع أهين point أعمل على sum of moment. Let us start with sum of forces along X. If we write sum of forces along X equals 0, and we consider the positive direction towards the right, what are our forces? We have +2, +2, plus AX equals to 0. This will give us that RAX is -4. Now, it's the same along Y. What do we have along Y? AY plus BY equals 0. We don't have any other force here. Here the weight is negligible. They didn't give us the weight of the truss. If they don't give us the weight, this means that we can neglect it. So when we write sum of Y equals 0, this is the positive direction. So by writing sum of forces along Y equals to 0, we have here plus AY plus BY equals to 0. We don't have any other force. And then we deduce that AY is equal to minus BY. Okay. Now we still need one equation to solve our system because this is a first relation between AY and BY. We need another one to solve for AY, BY. The third relation, for the third relation, you have several possibilities. You can write sum of moment about any point on your figure. Try in general to select a point that is simple to do sum of moments about. So for example, AX and AY both pass by A. If I do sum of moments about A, they will not do any moment. So they will not figure out in the moment. And then only BY as unknown will have a moment about A. So this equation, sum of moment about A, will allow us to get what is the value of BY. Okay, now how to get BY? We write sum of moment about A equals to 0. And as I told you before, whenever you want to write sum of moments about a point equal to 0, you should select a positive direction. You can take it as you like. You can take the clockwise as positive, or you can take the counterclockwise as positive. Now, if you, whatever you decide, you should put it near your equation. So let us say I selected the positive direction counterclockwise. Now, if I look at my figure, the first force here of 2 kilonewton, how I determine its moment, you remember the right-hand rule? Okay. Or you can just do it with your hand like this. This force is tending to rotate about A in this way, in the clockwise direction. So it's producing a negative moment. Now, how I get the value of this moment, the magnitude, I should find what is the distance between A and the force. So since the distance here is 1.5, then I should do 2 times 1.5. And because it's rotating clockwise and my convention is to take the counterclockwise as positive, then I will put minus 2 times 1.5. Now, for this force here, same procedure. For the direction, as you can see, it's trying to rotate into the clockwise direction about A. And because the distance from A is 3 meters, then I should do minus 2 times 3. Okay, so this is rotating into the counterclockwise direction. Plus, why we have positive now? Because look, this is BY, this is BY. Now, if you look at your figure, BY is tending to create about a rotation in this direction. This is a counterclockwise direction. And since I selected this direction as positive, so it's plus BY times this distance. This distance is 2. So I add plus RBY times 2 equals to 0. Sum of moment about A will give me the value of RBY. And since sum of Y equal to 0, I replace back, I deduce that AY is minus BY. So they are opposite to each other. So this will be 4.5 kilonewton upward, and this will be 4.5 kilonewton downward. So this is how I was able to solve for my reactions. And for AX, if I want to present it on the figure, look, I assumed AX to the right. When I solved, I got RAX equal minus 4 kilonewton. I can keep it to the right on my figure and put minus 4, or I can fix it. So I say, because I got a negative result, this means that my assumption was wrong. The reaction at AX is not directed towards the right, it's directed towards the left. So I can just erase here and put the actual direction and put close to it 4. Okay, so sometimes you cannot know before calculation if you have a positive or negative result. So you do your calculation. If you get a positive result, this means that your assumption is right. If you get a negative result, this means that you should have opposite sense. Now here, why you can expect that RAX will be like this? Because RAX is the only one opposing these forces. And both of these forces are positive. So of course, to have equilibrium in X, RAX should be equal to 4 kilonewton in the negative direction. Also, you could have expected that By is upward. Why? Because to ensure sum of moment about A equals 0, since these two are rotating clockwise, we need a force that will balance this moment. So it should create a moment counterclockwise. And this is only possible if By is upward. And finally, because along Y, the only forces are By and Ay. Since By is up, Ay should be down. Anyway, the roller cannot develop a reaction downward. Why? Because always the direction is perpendicular to contact from the roller towards the structure. Okay? Any question on this problem? Okay, yeah, let us solve one additional problem.
هو السؤال هو نجيب المومنت بس.
لا، السؤال جيب الرياكشنز، support reactions على A وال B، يعني AX AY و BY. Okay. Another example, this one. If you remember when I introduced to you the symbols, تتذكروا هذا الsymbol is for what?
Fixed.
Yes, this is a fixity. A fixity can develop 3 types of reactions: forces in X and Y, and also a couple moment. Okay, because a fixity will not allow you to move in X, will not allow you to move in Y, and will not allow you to do rotation. So it will develop 3 reactions at A: RAX, RAY, and a couple. Now, to calculate these reactions, so you have here 3 unknowns, you need 3 equations. Your 3 equations will be sum of forces along X equals 0, sum of forces along Y equals 0, and sum of moment about any point of your figure equals 0. You can select A, you can select B, you can select C. Whatever you do, you'll get the same result. Okay? Now, to start with, here, if you look at your figure, your load is due to a vertical force and a couple at B. Do you have any axial load acting on your system? No. So when you write sum of X equals 0, the only force is the reaction. So since you don't have a load in X, the reaction along X will be 0. So this is equation 1, which will give us the first unknown, which is RAX. If you put, for example, a force like this of 100 lb, then you will have a reaction RAX equal to 1000 lb. You will have a force equal to 1000 opposing it. But since you don't have any force in X, RAX will be 0. Now, second equation to write is sum of forces along Y equals 0. Also, you only have external load 2000 lb. If the weight was not negligible, you should add it, of course. So let's say they gave you the weight of the beam. You say the weight, if it's homogeneous beam, the weight will act at its middle. So they should give us the weight. If they gave us the weight, we say minus 2000 minus the weight plus Ry equals 0, we got Ry. But since here they didn't mention anything about the weight, this means that we can neglect it. And then the vertical reaction at A will just be here to oppose the downward vertical force of 2000. Finally, I still need to find what is my couple MA. To get the value of the couple MA, I can do sum of moments about any point on my figure, or A, or B, or C. Okay. Now, why A is easier to select? Because if you do sum of moments about A, forces RAX and RAY pass by A. So they cannot produce any moment about A. While if you select B or C, they RY Ry will do a moment about B and C, but not Rx. Why not Rx? Because Rx is passing by B and C. So it cannot produce a moment about these points. However, Ray will have a moment about B and C. Okay. Now, why it's better to take A? Because if I did a calculation error in Ry, to not affect my result for the couple. So try to take the point which will reduce, if you want, the need of using your calculated values. جربوا استعملوا الgiven as much as possible. So if I choose sum of moment about A, ما بعوز ولا RAX ولا RA1. Now, whenever I select a certain point, I should mention what is the positive direction I am considering. If I consider the counterclockwise as positive, then if I look at my figure, first I have the couple at A. مثل ما قلنا الكابل is a free, المومنت couple is a free vector. يعني وين ما كان بحسبه إذا الكابل حطيته على A بحسبه وقت أعمل sum of moment about A. وإذا في couple على غير point كمان I should account for it. So when I do sum of moments about A, because the moment is a free vector, wherever I put it, it will have the same effect. So it will lead to rotation. So I have MA plus 3000. Both are positive because both are counterclockwise. And finally, I have the moment of this force. As you can see, this force tends to rotate about A into the clockwise direction, which is a negative direction in my equation. This is why I should first put minus. Now, what is the value of the moment? To get the moment of this force, I take the distance from A to C. This distance is equal to 5 feet. I multiply the distance by the force. So I get that the moment produced by this force is minus 2000 times 5. And now I have accounted for all couples and all moment of forces equal to 0. Then I can find what is the value of my reaction moment at A. Okay, any question on this? Okay, I will send you these files on static equilibrium so you can remember the course material, the type of supports, and try to practice a little bit. So in case you have in the midterm equilibrium of a particle, or I don't think they will give you equilibrium of a rigid body, but maybe at least they might give you equilibrium of a particle. So you should be familiar with how to find the equilibrium conditions. Okay.
دكتور بس عندي سؤال بخصوص التنشن.
نعم.
انت قلتينا بالصف من قبل انه اذا في بولي وكل مايله في اوبجكت بس غير ماسس.
اوكي.
التنشن بيكون غير مزبوط؟
التنشن لا، انتبه على شغله. اذا انت عندك باكويليبريوم كونديشن، اذا الكيبل هو ذاته لا، فساعتها اذا الماسز ديفرنت المفروض يكون في، ما بيكون في اكويليبريوم، بيكون في موشن. يعني التنشن بتكون هي ذاتها بس في اكسلريشن للسيستم، يعني منه اترست.
اوكي.